While industry is responsible for a substantial share of global greenhouse emissions, there's no doubt that as the population grows, so does the human need for energy and materials. So much so that the International Energy Agency, so the IEA, estimates that industrial emissions have gone up by around 70% since the year 2000, mostly because the world needs more industrial goods. But at the same time, there's this environmental urgency to reduce harmful emissions from human activity. So the big question is, how do we meet this human need for energy and materials in the most sustainable way? Well, of course, we make the industrial processes as efficient as they can be. And then there's also this move to electrification as we progress towards the use of renewable energy sources. But how do we go about increasing the use of renewables in industrial processes? And are we running out of time? Well, the answer to that second question is no. And the answer to the first question is exactly what we're covering in this episode. As we explore the question, what will it take for industry to be powered by renewable energy? I'm Fran Scott, and this is the Process Automation Podcast from ABB. Today on the podcast, we have Stefan Basenach, who is the Senior Vice President of Process Automation Technology at ABB, and Lauri Peltola, the CCO of Coolbrook. But up first is Diego Hernandez Diaz, a partner at McKinsey and Company, and Diego is an expert in the green energy transformation. So, Diego, could you share with us how reducing the energy intensity and emissions of industrial operations could play a role within the energy transition?
Sure, very happy to. And it's a topic that really keeps me occupied day in and day out, right? If we look at the contribution of decarbonization from industry out to 2050 to achieve the 1.5 degree target, decarbonization of industry, specifically energy, is poised to contribute an outsized amount, close to 40% of all necessary decarbonization. Now, it's important also to distinguish in the energy transition the difference between electric decarbonization and energy decarbonization. And both of those are fundamentally important, especially in industries like cement, like steel, like pulp and paper, heavy and energy-intensive industries that have relatively ambitious targets out to 2050, where they'll have to be decarbonized 95% plus.
Understood. So what were those two different elements that you described? There was the energy decarbonisation and electric decarbonisation. Could you explain a little bit of those differences, please?
Absolutely. The work that initially got me started working with industry was around electricity. Folks are trying to decarbonize their electric consumption, specifically in SBTI or sustainability discussions, Scope 2 emissions. However, the electric component is only a part, and quite frankly, tends to be a small part of the overall energy consumption. A large part of the large industrials have an outsized consumption of elements like gas or coal to generate vast amounts of heat. That is also part of the energy equation and tends to be somewhere in the 5 to 10x the volume of the electric consumption. Now, we need to decarbonize both. Renewables are particularly good at decarbonizing the electric component. And now the next leg of the challenge is actually decarbonizing the energetic or the molecule side of the equation.
So how are industries looking to decarbonize?
One of the fundamental shifts, and let's take a decade-long history, is more and more players are looking to decarbonize their energy consumption. The way they are doing it has evolved dramatically. I think historically, folks always spoke about energy efficiency, and energy efficiency came into particular focus around the energy crisis in Europe over the last several years. Energy efficiency, I think, is a very key and critical contributor to our overall decarbonization scope, because the cheapest and cleanest megawatt hour of energy that anyone will consume is the one that is not used. I think, however, the question as we go deeper and deeper into decarbonization of electricity and energy will require us to integrate renewables and require us to pursue electrification. And quite frankly, those who are most successful will be pursuing a multi-pronged strategy that includes not one, not two, but all three of the different elements to pursue that decarbonization.
Okay, so in terms of when it comes to decarbonisation, it's that multi-pronged approach that we hear about time and time again. And so what challenges do renewables present if we are to integrate them into industry?
There's probably an obvious one, which is intermittency, especially if we're talking about renewables in the more traditional sense. And by traditional sense, I mean solar, wind, onshore and offshore. But that is something that by pursuing complementary profiles, by pursuing storage at various scales, we're starting to slowly fix. I think, by the way, the second element to that fix is to actually open up the scope or the span of solutions to include more than just what are the traditional renewables and actually start looking into elements like biomass, biogas, geothermal, things that are able to not only be complementary, but also fundamentally dispatchable. The second point, and this is perhaps the slightly more challenging or interesting one, is what I call time to volume. What I mean by that is integration of renewables is critically important. However, our ability to deliver renewables at scale and at speed is constantly being challenged. As an industry, we've more than doubled the rate of installation twice in the last 5 years. And yet still we have fundamental issues around permitting, around supply chain, around availability of labor, our ability to build the grid to interconnect these. And the last element around the challenges is the business cases, right? There's more and more discussion in the marketplace today about a large penetration of renewables driving prices closer to zero or zero price hours that you may have seen in the news. That is fundamentally, I think, a very attractive and indicative signal of where things are going. But that does present certain very specific challenges to the business cases that industrials also need to take into consideration.
Okay, so progress is being made, but what role does process automation take in the reliable integration of these renewables into those industrial processes?
It's a very good question. And I think process automation and ultimately the degree of process automation that you're able to explore opens us up to something that we've talked about for a very long time in the energy space, but where the volume of reality hasn't been what we would have expected, which is demand side response. If processes are automated and can be triggered at any given point in time, industrials could, in a future world, then pursue hours or times of day in which prices are lowest and supply is highest because of that process automation. In today's world where we are still, by and large, I won't say everyone, but where we are still very much beholden to fixed time schedules and labor, that is a much more challenging process.
Okay, so by automating a process, you can make it run exactly when you need it to, be that when you have the power supply that you need or when the demand is needed, whichever one you are concentrating on, which makes total sense. But what about electrification? Because I always see that electrification is the first step to decarbonisation. Is it increasingly seen as this conduit to the renewables in the industry?
I would say it is a conduit, but part of the work that I do is in establishing that it is not the only conduit. Biomass is one of those. Geothermal is another one of those. But I think it requires three things. The first and perhaps most obvious, it requires a viable electrification technology. Now, we could talk about heat pumps for many days to come, but not all industrial processes are created equal. Some will require higher and higher temperatures. And when you get into the world of 1,000 degrees and higher, you need to have very specific technologies, and steel might be one of the best examples where they've developed the electric arc furnace to actually modify that. But it requires the right electrification technology, and there is a vast amount of industrial use cases that still need commercial availability of such a technology. The second is the behavioral readiness of industry. If we think about industry historically, and especially this is true in commoditized industries, they have been successful because they've, at least in my view, optimized an existing process to such a degree that everything runs incredibly smoothly and incredibly efficiently. Any modification to that presents a very human challenge in terms of actually having operators and executives buy into the decision to change. Completely outside of a business case or sustainability objectives. And the third one, which I can't forget, is a viable business case, right? I think one of the big arguments for electrification has always been, well, electricity is meant to come down, and therefore a move to electrification outside of the initial capital outlay will be an interesting one. I think the specific geographies and conditions of industrial players are going to be very important because it's not always black and white. And as we move forward into a renewable world where we still need to build a massive amount of grids, where we'll need to pay for that grid build out, and where we also know that as renewables increase, volatility of electric prices will increase, the business case, again, is just not as black and white as we would like it to be. It's part of our job to help solve that equation, but it remains one of the big questions.
This transition is not going to be an easy process, and it's looking at these elements we can use to help industry along the way. And one of those elements is something we talked about in one of our earlier podcasts, which is industrial digitalization and analytics in the role of this energy transition. So, Diego, how do you think digitalization impacts the use of renewables within industry?
I think it's a net positive. Digitalization today allows us to do things that we couldn't have dreamed of a decade ago. We can understand very granularly how energy flows across an industrial site, what consumes energy, what doesn't consume energy. And going back to your previous points as well, analytics alone can drive percentage points of improvement in terms of energy efficiency in identifying outliers or things that are turned on when they shouldn't, ventilators, fan, etc. I think we haven't yet tapped the full potential, but I think it is one of those elements that remain incredibly exciting about the potential to drive decarbonization forward.
It's such an interesting time, I think, when it comes to this energy transition for industrial processes. In a way, it's this perfect storm. It's all of these elements working together to drive this change, and the technology is there now for this change to start to occur.
Couldn't agree more. I think one of the things that's driven activity in the last even 12 months is the fact that we are so close to 2030. The way I frame it is 2030 is tomorrow in terms of energy terms. And if that is the case, then action is now essentially to meet any of those 2030 goals, which has prompted just an unbelievable amount of activity and attention around the topic, because it's the first major milestone that we as a collective industry or nations are coming up on. If you think back to Paris and Tokyo over a decade back, this is the first big major milestone, and I think it'll be quite revealing in terms of what we've achieved and can we achieve it.
That was Diego Hernandez Diaz from McKinsey and Company. And what a fascinating insight into where we need to look and where industry needs to look in order for us to have an environmentally conscious future. Now, in season 1 of this podcast, we talked about distributed control systems, or DCS. And these are automated control systems that enable the operation of industries that help us live our everyday lives as humans. So ones that control energy, power, water, minerals, chemicals, transportation, a whole myriad of things that allow us humans to live. Now, what Diego outlined is that these industries, they do need to scale in order to support our growing population, but they also need to do it in a way that reduces carbon emissions. To help us understand how this is all possible, I interviewed Stefan Basenach, who is the Senior Vice President of Process Automation Technology at ABB. And I started by asking him what the next years are going to look like for him at ABB as he faces these challenges outlined by Diego head on.
I think that the next 10 years will be the most exciting years of my career in ABB, because we are in the middle of the most important global challenge to get the world net zero. When we talk about decarbonization, we talk about replacing fossil fuels by electricity, green energy produced electricity. And the good thing is that already today, electricity is used a lot in our industrial plants. For example, every motor has an electricity connection, and therefore it's not new for us. And with the rising supply of renewable energies, we step by step can introduce that in our plant and increase the portion of the renewable energy in the plant. It will be not at one jump. It will be a stepwise approach, shutting off one burner and replacing it with electricity, shutting off one power generation plant, which is using gas, and using a wind farm instead. And I want to highlight 3 aspects in that area. The first is automation, electrification will be much closer together than in the past. Electrification will be part of the process automation topic. The second aspect is that formerly decoupled sectors like steam management, heat management, electricity, feedstock management, those things will be coupled in the future. They need to be combined to make use of the renewable energy as good as possible. And the last piece is the technology driver. We will see a lot of technology innovations in the future that will help us in automation, in electricity, but also in digitalization that makes these changes possible to be implemented.
Understood. And so when we talk about these industries, what kind of industries are we referring to?
In process automation, we are helping our customers in those industries that build the backbone of our societies. The pattern in this industry is that those plants run 24/7. And those plants run not for a year or two, they run for decades. So a change in those industry area always means a long-term thinking needs to be applied. There is no quick change possible. And there's one part which is common in those industries. They're normally very energy consuming, which is on the one side is bad because when you need a lot of energy, in the past you produced a lot of CO2. That was the standard. But if you take it from the other perspective, if you find a green solution for those high demand, energy demand industries, we have a big impact on getting net zero implemented in our society. And this is exactly where we as an automation electrical company can add a lot of value to this transition by helping the customer to make this transition step by step.
You mentioned that these infrastructure industries, obviously they need to operate 24/7, but we all know, and it's the classic line, isn't it? The wind doesn't always blow, the sun doesn't always shine, especially in the UK. And so when it comes to using the electricity from these renewables, it's going to be intermittent, isn't it? So how do industries going about tackling this intermittency problem and still increase the share of renewables that's in the mix to make sure that they can run permanently?
Different to fossil fuels, it's not so easy to store electricity. When you produce it, you have to consume it in the same second. And also not so easy transportable in a tank that you can drive it over hundreds of kilometers and use it somewhere else. So we have 2 things to be solved. One is the production of renewable energy, which we are going very fast. And the second pillar we need to build up is storage. So whenever the renewable energy is produced, we need to catch it. In that millisecond, we need to catch it. And also here, technology is moving extremely fast. We have new ways of battery storage. We have more and more technologies that catch the energy in green molecules, how we call it. So producing hydrogen. So any kind of storing the energy to keep it when there is no wind, when there is no sun. This gives us the opportunity to stabilize the production and the consumption. The second thing is on the consumption side. So we need to make our plants' consumption more flexible. So when there's more renewable energy available, we can increase production. If there's less renewable energy available, we can reduce production. We can shut down parts of the plant that don't need to run all the time to keep those parts of the plant that has to run 24/7 always up and running at any time. So this kind of flexibility, again, calls for good automation, calls for stable, resilient electrical systems, and a good combination of both.
So with that in mind, if we think about the intermittency issue, and then we think about the storage issue, and with those being sort of dealt with, what other challenges are there if we are to adopt using more and more renewable energy?
So fossil fuels had been an unlimited source of energy. So this kind of unlimited supply has to be changed with a better managed balance between supply and demand. And this means we need to connect those sectors by combining the data. So let me give you an example. So you know your production plant of your industrial site, and you know the weather forecast. In the past, the industrial plant never cared about the weather forecast. Never. It was not important. In future, it will be, because it will define how many sun will shine, how many wind farms can run, how the battery capacity that is available. And based on that, those two things have to be linked together. Another part which is important, it's not always about producing more renewable energy. It's even better to make the process more efficient, because every energy you save doesn't produce any CO2 or doesn't consume any renewable energy, which is a limited resource. So saving energy is at least as important as making the renewable energy part of our value chain. So it's this combination, which is not easy, but for an engineer, that's a paradise.
Of course. And so I'm really interested to delve a little bit more into some collaborations and partnerships that ABB are involved in. And so could you give us some examples of those collaborations or partnerships that you found particularly interesting?
So we have a lot of partnership with our customers where we jointly work on pilot projects. We have tons of collaborations with technology startups. One to mention is Coolbrook for the rotodynamic heating. And another area we didn't touch so much till now is the digitalization. So when we talk about this flexibility, we talk about using the data we create or that are built or created in the plant today much better than before. I mentioned the weather forecast. We didn't care. Those are important data for the future. When you talk about lots of data, you directly combine that what we see in our private life with Google Maps, with Amazon. So the same amount of data are available in industrial plants, and use those data with digital applications, with new algorithms, with generative AI and this new concept. This is where we massively benefit from working together with partners like Microsoft, for example. So partnerships is really the differentiation, how to find good solutions for these new challenges or new opportunities we see coming in the next years. No company can do that alone.
That was Stefan Basenach from ABB. And just to draw on Stefan's words there, it's absolutely clear that collaborations and partnerships, they are the key to unlocking these opportunities for addressing this industrial decarbonisation. And this process of decarbonising industry, it is a huge challenge and it's needed, but it's not going to be easy. And that's because these industrial processes, they are and historically have been fueled by the burning of fossil fuel. And switching these over to renewable sources, it's a big challenge. But progress is being made. And we're about to hear about some of that progress. Rotodynamic technology. And this is a technology that's been created by Coolbrook in partnership with ABB. And it's a technology that aims to replace the burning of fossil fuels with renewable electricity as the source and to be used in heavy industry, so where high temperature processes are needed. And we are joined by the CCO of Coolbrook, Lauri Peltola. And Lauri is going to start by taking us through these rotodynamic products.
We have basically two different products. One which is called rotodynamic heater, which is an electrically driven heater to replace the fossil fuel burning in high temperature processes, whether that's in steel or cement or hydrogen or chemicals production. But also we have a rotodynamic reactor, which is an electrically driven reactor to replace the fossil fired cracker furnaces in petrochemical industry.
Absolutely. So cracking being the process in which longer molecules are broken down into shorter molecules. What is it that makes your technology so groundbreaking?
I think it's in a way an easy question to answer. It's the first and only electrical technology which can replace the burning of fossil fuels for this extreme high heat temperature generation. And that's what makes it groundbreaking. And it can do so with very attractive financial and operational benefits for the customer on top of the decarbonization. Traditionally, in these hard-to-abate heavy sectors, we have actually calculated that with our technology, we have the potential to reduce the global industrial CO2 emissions by approximately 2.4 billion tons annually, which is equivalent of 30% of the global industrial CO2 emissions.
Gosh, that is huge. And so can you share with us a little bit about how this technology goes about doing that?
It converts the electrical energy into heat with sort of very high efficiency. And how it works is that there is an electric motor which first converts the electricity into mechanical energy. And then when you have that mechanical energy, then the rotodynamic technology itself then converts that mechanical energy into heat. And how it happens is that it basically speeds up the gas that we want to heat up into supersonic velocities, and then it's being stopped into subsonic velocity. And this generates a shock wave, which then transforms, as said, the mechanical energy into thermal energy.
Oh my gosh, that is really outside of the box thinking, because so many of our industries, they work from that basic principle of like that heating up the water to create the steam, to get the movement. And if you get the movement, then you can make the thing happen. But what you're saying is actually this is not about making the thing move. It's about generating the heat. And you generate this heat in a way that I have never heard of before. And yeah, we've said this a few times, these hard-to-abate industries. But what are these industries? Where is your technology really making a difference?
Obviously, there's the chemicals and petrochemicals where the electrification of steam cracking is the primary application. But then you can consider also iron and steel, where you can do partial electrification of blast furnace. You can do scrap preheating before it goes into the electric arc furnace. There's a provision of high heat for hydrogen. In direct reduction of iron process. You can use it in slab reheating furnaces or any kind of furnaces that you currently have in the process. Then, if considering cement, which is one of the biggest targets for us, you can replace fossil fuels which are currently burned, for example, in the kilns or in pre-calciners. You can use our technology as part of clay calcination process, for example, and multiple other use cases as well.
In terms of your overall goal, it's about that switch from fossil fuels to renewable electricity. Now, before we spoke to Stefan from ABB Process Automation about just the problems that come with integrating those green energy sources, that are variable, they can be not always available. And so could you tell us about this problem of integrating that technology into your processes?
There's different ways how our customers have approached in solving this. So first, with many of them, we see that it's in a way important that they have been able to build a portfolio of renewable energy with different kind of sources in place. So they are not only relying on solar as a standalone, but they've also invested into wind power as well. And wherever it's possible, also they have hydropower available in the mix, so that they balance each other's out. So basically, even if the sun is not shining, then it can still be very probable that there's wind available. Then if you consider in a way beyond this kind of balancing the portfolio, our quite firm belief that this topic is in a way best solved not at an individual site, but more on the system level. So making sure that there's in a way sufficient grid power available and that the grid mix is as CO2 free as possible. Then if you consider even additional at site level topics, so obviously, our technology is also fully capable of working with different kind of power storage solutions. whether it's batteries or heat storages. Our technology is very well capable of working with those technologies as well. So in a way, trying to conclude on this answer is that we believe that you need to have CO2-free electricity available and a lot of it available in order for this net zero to be a realistic goal. And our technology, we believe, is the most efficient way to utilize that renewable power in order to generate the high heat.
But in terms of the future, where do you hope that it all leads? What in the next 5-10 years? What sort of timescales are we looking at? And what changes do you think will be made with your technology?
No, I think that's also a great question. And where we're starting now is this kind of first industrial demonstrator projects. And many of our customers do have 5 to 10 megawatt of additional power already available at the site. But then if we consider like full and proper electrification, for example, of a cement plant, it can easily require hundreds of megawatts of power in order to fully electrify the high heat. And this is obviously requiring quite significant investment into the grid structure in many places. And this will take a few years. But I think the key thing there is to get going and prove that the technology is actually applicable and it works and it shows a clear pathway towards full decarbonization. And that then encourages for these investments into the grid and into the power supply to be made. We are simultaneously now working on scaling our technology as well, so that we can go to the temperatures of up to 1700 with significantly higher thermal powers as well. So somewhere between 25 and 50 megawatt heaters instead of these 5 to 10 megawatt heaters where we're now starting from.
That was Lauri Peltola from Coolbrook. And oh my, what amazing technology they are developing in partnership with ABB. And it's innovations like this that are needed if we are to decarbonize industrial processes, and we're doing it one by one. But that does bring us to the end of this episode. Of course, a massive thank you to our guests today, Diego Hernandez Diaz, Stefan Basenach, and Lauri Peltola, for their brilliant insights and for taking the time to share their expertise. I'm Fran Scott, and the Process Automation Podcast is a Fresh Air production for ABB. Follow now from wherever you get your podcasts so you never miss an episode.